Last lesson, we started learning about electric current. And who remembers the difference between electric current and static electricity? All right, Andy?
The current, electric current maybe can move more easily in the conductors.
Okay.
And the static electricity.
All right. Yeah, that's pretty much the biggest difference. So static electricity is not moving. So when we can move charges between objects through static electricity and building up the charges in an object, but once they've moved, it's done. They're not moving anymore. Whereas current electricity is going places, specifically inside of a circuit. So like Andy said, we have conductors. And in the case of a circuit, the conductors are the wires which connect the different parts of the circuit. All right, so what about here? We have a flow of current electricity in this picture. Who remembers the different parts? So we have a battery. Do you remember the special word we use for battery in a circuit? Call it a power source. And then the wires are what? What did I just call the wires a second ago? Not conductors, but sounds similar. Connectors.
Connectors.
Yeah. And then the bulb, the light bulb.
Load.
Good, load. And what is the job of a load? It's using the electricity. Great, Andy. Yeah, it's using the electricity. And then we have another connector or wire, which has some metal conductor inside of it. And then there's a switch, and then more connectors back to the power source or battery, completing the circuit. So I am going to play what Tina wrote. She was kind enough to send me her reading the PPT since her microphone doesn't work.
Oh.
An electrical appliance is connected to a circuit head. Features: the circuit has only on pass. Any over circuit will open. One of the troubleshooting methods.
So, like last week, it is going to be your job to ask some questions. Since Tina's not able to answer us through here, I want her to send me messages in the group for us to listen to later. Okay? So Tina, in our group chat, I would like you to answer the questions that the other students have for you, and then we will listen to them later, either if there's time in class. If not, we will do them after class. Sample open-ended questions to help you ask some important questions about a series circuit. So I'm going to set a timer for, let's see what we have, for 3 minutes. And in that 3 minutes, I want you, all three of you boys, to come up with questions to ask Tina, okay?
So, in the current, the voltage will be smaller or just as is the same as put another light in the current.
Okay. So you're asking
The voltage.
about the voltage in a series circuit. And you want to know how many light bulbs we can add to a series circuit? Is that your question?
Can we add more light bulbs in the circuit?
Okay. All right, that's a good question. And Tina, you can answer the question in our group chat.
If you first open the switch, then close it. If the light near the battery well, close first. Or the battery far away from the light far away from the battery will close first.
Okay, so if there's more than one light in a series circuit, which light bulb will turn off first? Is that your question?
Yeah.
All right, so I've put those questions in the chat group for Tina, and let's see if I can help fill in some gaps. Okay, so here we have a series circuit. In a series circuit, all the electrical charges flow in the same direction along one single path. In a series circuit, the parts are connected like links in a chain. You know, like a chain. So you have the links in a chain. And the electric current passes through each part one at a time. Okay. So what would happen if one part of a series circuit is removed or broken? This question is for everyone. So look here, we've got the light bulb missing from this series circuit. All right, Andy?
I think the neither of the light bulb will be light.
Okay. Nail or Jerry, do you have any other things to say? Any other ideas? No?
It doesn't have a current.
Nail, what were you saying? Okay. And what makes you think that, Nail, how do you know Andy is right? Jerry, do you have an idea?
Because the two bulbs are on one way, and if take off one bulb, and so the circuit will just cut off, and the electricity can't go through from these two bulbs. So and the another light will go out too.
Great.
Question 1. What's parallel circuits? How many bulbs are there in one parallel circuit? How many batteries are there in one parallel circuit? Where can we put the switch? How many switches do you need? This is the battery, the two lines. And these two circles, and there are X in the circle, they're bulbs. And this two circle and in middle of them, there's this parallel circuit has two bulbs, one battery, one switch, one main road, and two current road.
So where can we put them, Jerry?
We can put them at the main road. If we put the switch on the access road, it couldn't turn off both two bulbs.
Do you think, Jerry? So he's putting the switch after the energy has gone through both the light bulbs on both parts of the parallel circuit. What do you think?
Yes, we can.
Why?
Because they are, and the switches are on access road. They are not on the main road. So the conduction can go on too.
Super. Andy, why don't you keep that picture around? When we get to our experiment in a little bit, we can try out that circuit, okay? Are there any advantages or disadvantages to these types of circuits? Why would we want a parallel circuit over a series circuit, Andy?
If the disadvantage of the the advantages of parallel circuit is it won't the current will still be on if we cut down one of the conductors.
Do you mean load?
Load.
Yeah. Because the conductor is more like the connectors or the wires that bring the energy to and from. All right, any advantages to a series circuit? Jerry?
And the disadvantage for the series circuit is if I close the switch, I can't let one of the light bulbs still be light.
Great observation. Brightness of a bulb less because power equals. Andy, you remember your formulas from last week? What does P equals IV mean?
Resistance equal current times voltage.
Well, this is a formula talking about brightness, so it's a different formula but uses the same vocabulary. So good job in remembering that. All right, and Jerry, you raised your hand. Do you have something to add?
Resistance. Maybe resistance is like the light bulb.
All right, actually, we're going to get into that right now. So, what affects electricity? So, voltage is the strength of a power source, and that's putting out 20 volts of electricity. What kind of battery do you have there?
This just it.
I can't see very well. What does it say? How many volts does it have?
And something to add.
Okay. 1.5 volts. Yeah.
Usually the voltage for the factory is 320 volts.
Oh, so when it's coming into the house, it's a higher voltage than what comes out of the wall? that is something that we'll also get into next week. So good observation and good thinking there. Any questions about resistance?
If the cross-sectional area is big, the resistance is small.
We will test this out in just a second. Let's get through the rest of this and then we'll talk about this with our experiment. So a path with no resistance, so there's no load, there's nothing taking the energy, is called a short circuit. If you connect a wire to a battery, it is a short circuit. And we've got 4 lights. You said 4 lights, right, Andy? 1, 2, and then let's bring 2 more. 2. And we're going to put the wire in. So this is a series or parallel circuit. Which is it, boys?
Parallel.
All right. All right, so we have 1 battery. I got it. Thanks, Andy. So we have 1 battery and we have 4 light bulbs. Now let's add in some switches, right? All right, so I don't know. What do you think, boys? We have all switches are open. The circuit is open. We close the switch on the positive end of our second parallel circuit. And look, everything is working. All 4 are lit, light up. And if this one is open, they all still light up. Except for this one. Huh, look at that. This is interesting. So when we close this circuit, it's actually turning this light bulb and this light bulb off. Is that what you thought would happen, Andy? But when I open or close this circuit, these 2 shut off, but these still work. Let's see what happens here. Very strange. Look. So we've got, now this one is very bright, and these 3 are not as bright. What do you think? Should we try adding anything? What could we add to make all the batteries brighter, or make all the lights brighter? Should we try connecting the battery to a coin? What do you think will happen?
Nothing happened.
Nothing?
The electricity will go through the coin.
In a short circuit.
You think we'll get a short circuit? Well, we could test this by adding a fuse and seeing if it breaks. Let's see what happens. Ah! Did you see that? It caught fire and we got a broken fuse.
If we don't add the fuse,
If we don't add the fuse,
the batteries were broken.
Yep. It's going so fast and everything's catching on fire for you guys. So this picture here is a circuit that Tina made, and this video here is one that Jerry made. Jerry added switches, and I think, Jerry, can you tell us something about the circuit you made?
This one is parallel circuit.
Cool. And is this kind of
This one is which that Andy drawn it.
Yeah, I thought so. It looked familiar. Well, cool. That's very ingenious of you. And this one is Tina's circuit. What do you guys think of Tina's circuit? What kind of circuit is it? Parallel circuit? I think so too. How many power sources are there in Tina's circuit?
2.
2. And what else can we say about Jerry's circuit and Tina's circuit? We have very bright light. So do you think that Tina's circuit needs 2 batteries to have such bright light?
No.
No? Why is that?
Because Jerry's circuit only uses 1 battery and it's not so light.
Cool. Yeah. All right. So what do you have here? Can you tell us the different parts, the different...
There is a switch and 2 batteries and 2 light bulbs. And this is a series circuit.
Series
And the
circuit.
next-
Good job.
Next one is parallel circuit.
Oh, cool. You made mini circuits.
And the last one is just for fun.
Whoa, what's going on there?
I don't know how to think about it.
All right.
There are 1 big switch and 2 small switches.
And what
this
do
is
the
a
different
fuse
switches
maybe.
do?
When the big switch open, you need to open the small switch, and when the small switch is open, the light bulb will be light.
Cool.
And if the small switch don't open, only open the big switch, it won't be light. And only open the small switch, but not open the big switch, the light bulb will not be light too.
Cool. So what I see here, do you guys remember what Andy said those circles with the X are? What does the circle with an X mean?
Light bulb.
Light bulb.
Yeah. And then we had a little piece of the circuit missing. What was that? There was a gap.
Switch.
Yeah.
Which?